right, so we're
You're
live.
live.
All right, guys, welcome. Industry skills. Let's talk about it. My name is Isaiah Jones. I am the secretary slash event organizer for the Google Developer Student Club here at LSU. Today we have a workshop that is going to be covering just some technical interview questions and some assessment practices that we're going to do. But this is one workshop in many. This is just an intro to what this workshop is going to be about. And now let's talk about it. So, introduction to this workshop. The aim of this workshop is to help students transition from classes to securing an internship or full-time position. We'll be covering these three topics. Normally, I would start with resume building, but in the time that I chose to prepare for this, I didn't get in contact with anybody from LSU Student Services who is an expert on resume building. So today, I really want to speak on what I have the most experience with, which is online assessments and technical interviews. And then in another workshop, we'll talk about behavioral interviews. But I left it in this order on purpose. Resume building is the most essential part. Moving on to online assessments and technical interviews. And next, you have your behavioral interviews. So we're actually gonna, let's talk about some of the computer science careers that are available to you. You have software engineering, data science, cloud computing, cybersecurity. A lot of these fields are really deeply interconnected. Starting with software engineering. Software engineering was my initial passion when I came here to LSU. I wanted to be a game developer. Software engineering kind of envelops that general skill. I want to be a developer. You can be specialized. You can be a full stack developer where you work on the front end and the back end. You can do web development. You can work on app development using all sorts of tools here. But then I learned that I really like data science. It took some time for me to explore myself, but as I learned outside of school through YouTube, I really learned that I have an interest in data. Is the mic working well?
It's a
Can you
little
guys-
quiet.
It's a little quiet on the stream.
Somebody said online.
Okay, that's cool. I don't mind repeating myself so the people at home can hear. How y'all doing, by the way?
You gotta get the gain volume.
Let's go. I love the energy in here. Let me know how this sounds. Let me know how this sounds. All right, testing, testing. Testing. All right, you think we can continue here?
Yeah, no.
All right, so I'm gonna go back. I'm gonna talk about this slide again, okay? So in this slide, we're gonna cover some of the general computer science careers that you can go into. These are the concentrations that are specifically offered at LSU. So I wanted to cover them, but I really wanted to hit on the fact that a lot of these are deeply interconnected. When I first came to LSU, my major was computer science with a concentration in software engineering. The thing about that is when I was young, I played this game called Roblox, and I really wanted to learn how to code because they gave me the opportunity to explore that really early. And I came in wanting to be a game developer. But software engineering isn't just game development. It's more of a general purpose. These people are more general purpose programmers. They still have specialties like front end and back end. You have people that work across the entire stack, full stack. You have people that work exclusively on apps. You have people that work on web development. But it seems to be a more open-ended, more wraparound term for people working in computer science. But as I experienced computer science, I really got a love for data science. And that's what I've been taking most of my class in data science now. I got interested in YouTube. I started watching videos about neural networks. I started watching videos about machine learning, and it really grabbed my interest. Like, this is what I really want to do. And then I got a friend of mine up here talking about cloud computing. Come up here. Come on. I don't know much about cloud computing, man. You come speak your piece.
Yeah, so everybody hears cloud computing nowadays, and it's such a broad term to where, just like if somebody says, oh, I work in tech, I'm a computer science major, it doesn't really tell you a whole lot. So some of the little subsets within cloud computing, cloud engineering as a whole. So first and foremost, we have network engineering. You can have the best data center, the best code running your cloud. You can have the next breakthrough in cloud technology. But without a network to provide reliable data transport from your data center to your clients that are paying for your services, you really don't have a whole lot. So essentially network engineering, what this is going to encompass is all your routing, your switching, to make sure that you have all the proper underlay infrastructure in place to be able to serve your clients. And so DevOps kind of falls between the two, between cloud architecting and network engineering. What DevOps is essentially automating your environments. So that way you can have a clean, stable environment where you can have a lot of great monitoring, lots of automation to be able to roll out configuration changes pretty much on the fly. And version control software will also kind of fall into this category as well, such as Git or any other in-house developed products that a certain company might use. Some other stuff that you might encounter here would be Docker containerization to have a small little virtual environment to run your applications in. And finally, cloud architecting would be kind of whenever you think of cloud computing, these are the people that are going to be using the cloud platform, designing stuff, whether it's in AWS, GCP, Microsoft Azure, and kind of developing what you would expect from an on-premise style infrastructure, but developing this in the cloud to where it's a lot cheaper. You don't have to pay for the electricity, the server costs, the cooling, and you also get to cut out a lot of the low-hanging maintenance, such as patching your servers and things like that. So with cloud, you also have to worry about keeping your things secure, and that's where cybersecurity is going to come in as well. So cybersecurity, sorry about that. So what cybersecurity is keeping all your stuff locked down, safe in the cloud or on-prem as well, to make sure that all of your data that you have is going to be kept secure. Only the people that are supposed to have access to it will, and mainly just preventing incidents such as what we saw with the pipeline that got hacked last year. So some of the categories that we're going to touch real quick on cybersecurity is penetration testing. This is probably, in my opinion, the most exciting part of cybersecurity. Essentially what penetration testing is, or pen testing for short, is you're going into an environment. You might be an ethical hacker that gets hired from, like you're a consultant, you get hired from a big company, and they basically say, hey, come try and hack us. Show us where our vulnerabilities are. And then after you do that, you see how far deep you can get into somebody's environment, and then you write up a report and say, this is where your weaknesses are, this is how I got into your environment, this is what you need to fix to prevent this from happening in the future. So pen testing can be really fun. It's something that I really want to get into in the future as well. The next category we have is malware analysis. This is a very, very technical subset of cybersecurity. Essentially what malware analysis is you get hacked, all right? They put some malware onto your network, your infrastructure. What a malware analyst would do is they would extract that sample of malware, bring it down to assembly level, deconstruct it, reverse engineer it, and figure out exactly how this is working to impact an enterprise environment. This is extremely complicated, obviously, as it involves assembly programming, but this is a very interesting subset as well, because we start looking into kernel levels as how this got through, whether it's a Cisco kernel on their switching or a Palo Alto firewall, how it's able to bypass this on the network side, and then also how it's going to be able to exploit an operating system such as Linux, Mac OS, or Windows. And finally, security architect. This is kind of similar to a cloud architect in the sense that you're architecting something from a policy level to an implementation level. It can be purely technical, it can get up to the managerial level as well. But your security architects are the people that are going to be designing an entire security environment essentially for an enterprise. They're going to set forth the policies on how access control is going to be done, whether you're going to be using, what protocols you'd be using, whether it's Radius, TACX, Leap, 802.1x, just to name a few. But like I said, these people are going to lay out your whole policy, and then they're also going to go on to the side of user awareness. So they're going to be the ones that are going to come up with the policies on how we're going to train users on common tactics such as phishing, social engineering, as well as training employees to be more aware physically. A popular technique nowadays too is people that have badge access to a certain facility. Somebody could just tail in right behind them if an employee's not paying attention. So that's pretty much what cybersecurity will do. They're going to be trying to keep everything locked down. Cybersecurity is incredibly important, especially in today's day and age. The amount of money that gets lost anytime an organization is hacked is tremendous, and given the right circumstances, the type of data that's stolen, this could definitely lead to an organization's downfall, unfortunately. There have been several companies that have had case studies done on them as to how a hack went through, and that ultimately led to the downfall of the organization. So it's just very important to kind of keep all these things in mind, especially with the cloud computing, network engineering, cloud architecture, and DevOps. They all go hand in hand with cybersecurity. anytime you're designing solutions, it needs to be done hand in hand. You're always going to have to consider security. You're always going to have to consider engineering, and they have to go hand in hand to make sure that you have a robust and reliable infrastructure. So that's my little ramble spiel on the two areas that I'm most interested in tech, cloud computing, or really just IT infrastructure as a whole. I love that, really love that field, and also cybersecurity. Not my forte, but I'm learning a bit more as I continue to get more experience. So I'm going to go ahead and turn it back over to Isaiah, and he's going to continue on.
Thank you. Thank you so much, Nick. I'm glad you hit on a lot of important points that I don't fully understand yet, but you really did a great job of covering the fact that all of these are deeply interconnected. For example, with your app development, you might develop an app that stores data. You might want to use this data to learn more about your users. You might learn through machine learning that you can find certain patterns. And you might learn with artificial intelligence that you can learn a lot more about people than you think. And with cloud computing, you can't just have all of this data stored in a physical storage disk. You need to work with cloud architects. And like I said, this is an area that Nick knows better than me. But I do understand that we have to work together in order to accomplish this goal. And with cybersecurity, you have to keep your secrets safe. You know, not only do you need to keep it safe, but like you said, social engineering. You need to keep the people safe. We all have to work together in this big goal. It's really important that you understand that all of these computer science careers are fundamental to each other. They all help each other, and they all manifest in different ways, you know? But the bigger picture here is that we're all in this together. So finding the right choice for you. People are gonna talk about some of their sample projects. Adam, would you like to go first?
Yeah.
All right.
So one thing that I like to really talk to everyone about is really trying to choose your career path, you know, whenever you're coming into college, right? So like they've shown in the slide before this one, you really have like those four main branches. But what people don't really know is like in those four branches, it gets extremely diverse and it goes extremely deep, you know, and each one of those subcategories is even more subcategories. So really trying to find the right choice for you is what we want to help y'all with today. So up here on the screen, I have some of the most popular sample projects for, I would say, beginner and intermediate students. So for example, for software engineering, you have your back-end development, right? So some sample project ideas could be creating a RESTful API, creating a web scraper to collect data off the web, maybe even creating your favorite bot on Discord or even on Twitter. And then you have like your data science projects, like big data, right? Where you can create a resume parser or try to create a text mining project where you can mine through the text file to find certain words. And in cloud computing, you have things like creating your own simple home network, right? Now that sounds crazy. You're like, whoa, like I can do that? I promise you can. All this is on, you can find these projects available online, and even through us, through our own GDSC, we'll be involving y'all in some of these small, simple projects. So, and also in cybersecurity, as you can tell, we have like in malware analysis, you can analyze samples of well-known malware and learn how they work. All of these are just simple projects that you can really incorporate into your own like life when you have time, and then try to find where your choice is. Because a lot of people, kind of like what Zay said, you know, he started off, you know, I like video game design, I'm all for that, right? But whenever they really see where their strengths lies, he sees his strengths lies in data, right? That's where he wants to focus his studying, right, in data. So really trying to find the right choice, that's a really big thing I want to push to everyone. It's really important, and I think a lot of people can really find their career path here in the GDSC. I'm going to pass it back to Zay. Thank you, Zay.
Yeah, thank you so much, Adam. Like, you hit on a bunch of critical points. And first, before I continue what I'm going to say, I just want to ask, does anybody in here have any questions? How do y'all feel about the pace of the program? Is it okay?
I'm checking the chat to make sure if you want to ask questions, I'll bring it up to you.
Thank you. I appreciate that. But before I switch this slide, like passion plays an amazingly huge part. And what you mentioned about diversity plays a huge, amazingly important part. You know, I didn't know that I wanted to get into data science. I kind of just stumbled upon it, and sometimes you you just feel an immediate connection to what you want to work on. It started with data science, then it slipped into machine learning, then it slipped into artificial intelligence, then it slipped into biology. I want to learn about all of these different things. I feel deep down that all of these fields are interrelated and I want to learn about all of them, but I can't do it by myself. That's why there's other people out here who concentrate in software engineering. There's people who concentrate in cloud computing. There's people who have cybersecurity expertise out of this world. Like when we all come together, it's amazing. So now let's really focus on the getting the jobs part now that we covered the careers. So let's talk about the application process. If it's a bit much if you haven't done it yet, I'm just saying. Applications generally start off with the resume screen. It's important to have a resume that communicates why you're a good fit for the job. And that goes with data science and machine learning. People screen resumes. These companies screen your resumes. They don't have time to read them. If you have the right information in your resume, it will make you stand out way better. After a resume screen, or sometimes simultaneously as you submit your resume, submit the application, the company will send you an online assessment. But we're gonna talk about online assessments further on in the slideshow. Now the next part is a mix of factors. At some points, you might have a final behavioral interview. A lot of companies, they don't make you go through a strenuous process. They just want to make sure that you're a company fit. Some companies have what they call power days, but that's just a long and short of a bunch of interviews just to see who you are as a person. So now let's talk a little bit about that online assessment part. I mentioned that, normally we'll talk about resume building first, but I want to get a resume expert in here, to speak about that. So let's talk about the online assessments and technical interviews. What is an online assessment? An online assessment is a coding test. It's usually hosted by a third-party website where developers solve one or more questions under a time limit. It's usually focused on data structures and algorithms. They can be proctored, and more than likely, it's the first official step of your interview process after the resume screen. Technical interviews, on the other hand, technical interviews are also coding tests, but not necessarily coding tests. They want to test your technical knowledge and your understanding of the subject matter that you're talking about. But the thing is that they're usually face-to-face with an engineer from a company. They're not just trying to see your technical knowledge, but also how you process that technical knowledge. That makes a huge difference. It can focus on data structures and algorithm, system design, general programming questions, general language syntax questions. They just want to see your proficiency and how well you can communicate your idea. And I went into my next bullet point by complete accident. But yeah, it's usually later in the process. It's after you've passed the online assessment and the company is actually interested in who you are. So what does all this new information mean to me? Like, what do these coding problems even look like? Generally, most coding problems ask a developer to think of an algorithm to solve a generic problem. It can also require a developer to focus on applying certain data structures to solve the problem. Those two are not mutually exclusive. And maybe if you're not into your later data structures and algorithm class, this might sound a bit overwhelming. Don't worry, I'm coming to that later. Data structures and algorithms are important tools for developers to solve complicated problems. But how does solving a coding problem indicate that I'm a good fit for a job? Well, it's more so that developers often need to take a very human problem and create a solution that a computer can understand. But does this mean I have to study outside of class for interviews? It honestly depends on the company that you want to work for. A lot of companies don't even make you go through this process. But the higher tier the company, the more prestigious the company, they will ask you, and you should study outside of class, especially data structures and algorithms. It's not so much that you don't have the understanding, but you learn a lot better once you've seen information over and over. It becomes second nature, it becomes almost instinctual, and you get to think a lot more creatively if you keep practicing these things. So let's talk about resources. This is just a small list. It's for internships and full-time opportunities. I listed levels.fyi for that is my favorite website. It tells you just how much developers can truly make out here. And I don't know about y'all, but money can be a huge inspiration for wanting to achieve your goals. If you struggle, me personally, I have ADHD. And so sticking to practicing coding questions all the time is really tough. But I want to make $500 million a year. You know, that's a bit greedy, but I'm exaggerating a bit, okay? Looking at levels.fyi will keep you up at night being like, Lord, if I can just solve these coding questions, I can make $400,000 a year like that. LinkedIn.com. This is more of a connections tool. Connections are way more important than you think. Well, y'all might already know this, but I just wanted to hit on that point already. Connections really can help you if you are struggling in that maybe you're not that strong in coding. Maybe you're like me and you struggle to focus on coding interviews. People who know you can see how you think and they can advocate for you if you're struggling. And that's important. For full-time opportunities, I use the same two websites. There's so many more resources. Adam, do you want to contribute some?
Yeah, I was gonna say.
Yeah, I don't know if they can hear you on the
No,
mic.
you can
Okay.
share it with them like as if I'm asking you a question. But handshake is a really big one for like students here at LSU.
Right.
They have like their own thing for schools, like in universities. No matter what university you go to, they have like a handshake thing for your school. So it's also really big to like sign up for that as well if you're a student.
Yeah. Just
share that with them
just to
as well.
say this again, handshake plays a really big part. You know, I forgot I used handshake. It's really easy to forget about because the school offers it. I guess I don't know. It's not like the big boys like LinkedIn, but it actually is a really useful resource that I should pay more attention to. All right, so now let's talk about solving these problems. Maybe if you haven't been in data structures and algorithms already, or maybe you don't spend time outside of class studying for interviews. Let's talk about how to solve problems like a robot, because you're not a computer. Let's talk about what computers are really good at. Computers are really good at executing orders, but not necessarily creating the logical reasoning for solving a problem. This is where people come in. We figure out the logic to solve a problem in human terms. Then we try to translate our thoughts to things that we learned in class and to orders that the computer can understand. So, how do we communicate with computers effectively? That's where data structures and algorithms come in. Yeah, that's the reason that we take this class. Algorithms are tools that provide developers with easier ways to translate logic into computer orders. Developers develop their own algorithms for most work, but some common problems have common algorithms. For example, selection sort, depth first search, Dijkstra's algorithm. And the thing about these algorithms is that you can find a common problem, right? And a group of developers can work on solving this common problem, and they can come up with a great solution. I'm thinking of NP hard problems right here. Like they have all the framework right there. They want to solve this problem. They create these common algorithms so that developers in the future can come and blow them away. And it's because of their work that they built on, and because the developers were able to see their thought process and finally understand what's going on, that you're able to make these great strides and leaps in human ingenuity. Data structures are tools that provide developers with easier ways to handle the data that are required in these algorithms. Some examples of this is hash maps. Hash maps, arrays, and linked lists. I would like to go over hash maps, arrays, and linked lists just a little bit. I do kind of want to use this as an example. I'm not sure how well the camera can see this, so I'll just put it a little bit over here. How's it look on camera, guys?
Angle it more toward.
Yeah, just angle it a little bit more, but that's about it.
Okay,
Yeah, like
and
that.
everybody over here is good. So what I really want to talk about is that data is interchangeable when you store it in these structures. Like a hash map is a very basic structure. It has you have like a key, and that key has access to a value. And that is a really good feature of it, but there's a lot of other important features that really makes it great. If you have a huge hash map with 1,000,000 keys and you want to only access one particular value, you don't need to know the rest of the keys. You just need to know this key to get to this value. That's extremely efficient when you're trying to look for that type of thing in data. Where's my eraser? It's a bit sticky, but just work with me. Then you have arrays. Arrays are probably like the first data structure that we really learn about in these classes. Arrays store data. Some languages have them in fixed sizes. Some languages are able to expand them. But the thing is, they store data in like a comma delimited. I forget the word. It's like comma delimited. Thank you. Let's try to draw this again. They store data in a comma delimited natural order. They're inserted in the order. You can access any element in the array by its position. If you know the position of the data that you want, you can access it. It's really easy to get the first item. It's really easy to get the last item. It's a bit more difficult to traverse through the middle. Hash maps kind of have better tools for that. But this is really good if you want to go through things iteratively. You know, if you want to apply some algorithm to each item in an array, it really shows you, like, it's really good at doing that. Y'all following what I'm saying? Okay. So linked list, you know, I don't think I necessarily need to cover all the data structures here, but I do want to hit on a point where these data structures are interchangeable in a way that you can have an array of hash maps. Maybe you have a bunch of data. Maybe you do want to access these different hash maps, you know, sequentially. But the information in the hash map, you have a particular key for it. You can combine those two and make a great data structure that can solve a very particular problem. Does that make sense, guys?
Yeah.
Is it, y'all following? Any questions about what I've covered so far? Anybody wants to speak on maybe the pace of how I'm going here? Is it good?
That's good.
All right. So, okay. So first off, we're gonna exit the slideshow just because we're gonna code physically here, and I have to exit the slideshow to code. But we're gonna talk about solving a problem, and we're not just gonna talk about like how do we code it. We're gonna talk about what is the problem, how would a person solve this, using the data structures and tools that we learn. How can we apply our human logic to what computers can understand so that they can help us help them? So let's say the problem says we're given an array named nums. We define a running sum of an array as running sum I, and that's equal to sum of nums 0 all the way to wherever I is currently at. We return the running sum of nums. Now, if you don't code all the time, if you haven't practiced coding questions like this might be unfamiliar. But let's just think about what they're telling us real quick. Where we're given an array of just random numbers, right? And they tell us that they have something called a running sum. And it's defined as if I is just a given place in the algorithm, let's say I is right here in the middle, the running sum is all the elements that add up to I. That makes sense? So as a person, if we were to be introduced into a problem like this, let's say in like a math class or something, it's not coding, how will we solve this? I know in my head, I'm like, so I know that the number we're looking for at I is the sum of the past elements. So I need some way to keep track of the elements in the past so that, wait, if I continue to add on to this variable, if I continue to add on to what I'm keeping track of, I'm gonna have my solution, right? So I try to solve this like a person. I might solve it on my hands. Let's say you have 10 fingers, and you ever count on your hands. You count down from 10. Let's say you take away 2. You see you have 7 left. It's somewhat along those lines. So if I have 8, right, and there's no other element before 8, I know that my running sum is currently 8. I can update it. If I see that 2 is next, I already know that I have 8. Let's add 2 to it now. Now we have 10. And since we're constantly updating it, we don't need to keep going through this array over and over. We have something that we're constantly keeping track of, so that when we're constantly keeping track of it, it makes it easier for us to get this answer. So in class, in data structures and algorithms in 1350 and 1351, they teach us about variables. They can store a value, and you can update that value. They also teach us that you can iterate through arrays. You do iterations with for loops. So applying how I would approach this problem and applying what I learned in class, that is the purpose of these coding interviews. So let's say I'm gonna, y'all think I should do pseudocode, or y'all think I should code it? What y'all think? I still want to kind of introduce the idea before actually coding it, because this code will be in Java, which most people at LSU know Java, but I want to just have like the basic approach that I would do. I would have a variable. I would just name it like current sum, right? And the reason I name it current sum is because when I look at this variable, I want to instantly know what it represents, right? And if anyone else looks at my code, I want them to know what it should represent. And so by default, we know that the running sum is added up. So if there's nothing in an array, it's going to be at 0. So let's set it default at 0, right? Now we want to iterate through this array. Let's say we have a for loop, and we're not going to write all the technical stuff. We're going to say for each element in the array, we're going to apply some operation. So we know that an element, they refer to it as nums0. This array is named nums. So if we're going through each element here, we have nums of whatever element that we're at is going to be, I wrote it a little bit backwards, but the current sum is going to be increased by whatever number that we're currently at. So we'll add whatever number that we're currently at. And so thinking about this, does that seem like a reasonable approach to solve this problem? For each element, just continue to use the variable and increase it by where we're currently at. That makes sense? Yeah. All right, so this is where learning languages actually applies at. Because, you know, at LSU, we learn Java. So I wanna code this in Java, but I wanna point out that understanding this logic is, my personal opinion, much more important than actually knowing the syntax of the language. But if you don't know the syntax of the language, how are you gonna solve the problem in the first place? You know, it's a give or take, but I do have an emphasis on one instead of the other. So now looking at this, we have a function here. It's in a class called solution, and it has a public function here, which means that anybody can access it. It returns an integer array, and it's called running sum, and it takes in an integer array nums. So we need to create an array here. When I explained the problem, I did mess up a bit. We need an array that we put current sum into an array that we return. So my fault, and if y'all want me to go over the problem again, I can. But I'll correct it here, all right? So in this function, the first thing we're gonna need is we know we're gonna need the output as an integer array. Let's go ahead and create that. Let's call it answer. Our answer is equal to It's an integer array. We name it answer, and it's equal to a new integer array. This is just new integer array is how you instantiate an object in Java. It's not the same in every language, but object-oriented program languages generally have this function. And we want to, in Java, you have to set the size. You can't extend arrays or shrink arrays. But we know that the running sum array is going to be the same size as the nums array. So if we know nums.length, how big the array is, we can use that because we know that they're going to be equal in length. So now, let's also, the variable current sum is very relevant. So let's have a variable, it's an integer, current sum is equal to 0. Because it's going to start off at 0 by default, right? We already agreed on that. And so now all we need to do is iterate through our array.
Could you move the cursor, please? The cursor.
The cursor?
Yeah, thank you.
Okay, I'm sorry. So now all we need to do is iterate through our array and put whatever the current sum is at this time into the answer. So let's say and I'm just gonna walk over this. In Java, you do for loops. I'm sure most of us understand it's for int I is equal to 0, I is less than nums.length, I plus plus. This is just your basic for loop. It's going to iterate from the very first position all the way to the end of the array. It goes from 0 and it increases by 1 every time. It doesn't do the indentation for me, so y'all have to spare me a bit. So we're just going to say that answer of whatever element that we're currently on, since I is going to go from the beginning, answer of I is also going to start from the beginning, is going to be plus equal. Oh my God, the mic fell. I am so sorry. Actually, for technicality's sake, let's say we're gonna increase current sum first. So current sum plus equals whatever nums I is. So that's what we want to do first. We want to add on to the element from nums, and then we want to put current sum into answer. So after that, the slide is giving up on me. Don't worry, we will make this work. Let's just get some extra space here. So now we want to update answer. Answer, and it's going to be in the same place as nums because we're doing the current, like the running sum is updated in the same place that we get the incrementation for current sum. So answers I will be equal to current sum. Right? And then after we get done iterating, we want to return our answer array. We want to return answer, and ignore that is capitalizing things. You know, this is not, yeah, you know, we're just walking through this at this point. Now, there's a couple of things that I do want to cover, like edge cases. For this problem, we're doing basic introduction, so, you know, I don't want to cover too much at one time, but I do want to hit on edge cases. Sometimes, you know, especially during coding interviews, they purposely don't give you a lot of information because they want you to ask questions about the problem, and they purposely leave holes, like you need to test your solution for holes. So what if the numbers inside of nums are bigger than the integers that Java can hold? Java can hold, I think integers are, is it 16? 2 to the 16th power, and then longs are 2 to the 32nd. It's, I don't know, you know, off the back of my hand, but you know, the people who ask you these questions in interviews want to know if you have that random knowledge, you know, and you need to consider that when solving these problems. So I just wanted to mention that. But the last thing I want to do is just like, let's walk through our code and compare it to how we said we would do it in a human way. So what we do is we create a data structure that keeps track of whatever the current sum is. So the problem asks for the running sum at, at any given number. We create a data structure that does that. Then we create an integer that keeps track of whatever the current sum is, and it starts at 0, right? We talked earlier, arrays are really good for iterating through. So we use a for loop, which is a good application on an array. We iterate through every item in the array, and we first increment the current sum. Whatever it is in the numbers array, we want to increment it by that. And then this current sum is continually growing as we iterate through the array. So we want to put into answers what the current sum is. And then after we get done, we want to return the answer, and that's how we get our solution. I want to say that the really important part about this is, I mean, like I said, doing the code is really important, but being able to communicate that idea to other people, being able to write code that is readable to other people, being able to work with your interviewer to make sure that you're covering those edge cases, you're making sure that your solution doesn't have holes in it, making sure that your code is scalable. Those are things that interviewers look for. You know, this is just a short overview of what these online assessments and technical interviews look like. So, yeah. Any questions?
I had a quick question for you. Do you think like the interviewers are gonna ask you about like the time complexity of like your code, or like
Yes.
how to make your code like efficient or something?
Of course. I completely skipped over that. I am so sorry. That is something else that you learn in data structures and algorithms is time complexity and space complexity. These are things that most of the time you're sacrificing one to increase the speed of the other or increase the efficiency. I was looking for that word of the other. So let's talk about some time complexity here. First off, is everyone in this room familiar with time complexity? Yeah. Okay. So we know most of the big O notation. You have O of 1. That's the fastest you can get. You have O of log n, which, as it tends towards infinity, it is very close to O of 1. You know, especially in the beginning. You have O of n, which is linear. You have O of n squared, which is quadratic, and it continues. You have n 2 to the n, which is exponential. That is the worst time complexity. So let's think about what the time complexity of this algorithm would be. So we know that a for loop is iterative, right? And we know that we're going through one element for each iteration, right? So think about we're going through n elements. So we have one action in this for loop that we do n amount of times. So if you think about it, our time complexity here is O of n, right? Does that make sense? Because we're making a whole bunch of O of 1 operations n times. And being able to explain that, not just knowing that for loops are O of n complexity, but knowing why this tends towards this. Because with your more complex algorithms, O of n can be very, very slow. Even though it sounds fast, it depends on the operations that are happening. You can have a whole bunch of O of 1 operations inside of a for loop, and it can make it very expensive. It'll still be O of n. It can be 8 operations n times, and it'll be O of 8n. It still boils down to O of n, but if you can have O of 3n, that's so much better for expanding your code. Space complexity. Space complexity is very similar to time complexity, but it talks about space. I mean, it talks about how much space you're using on your disk, maybe you're coding in the cloud, how much space you are consuming that your computer or your whatever device you're using needs to operate. So let's say we're using arrays. Data structures cost space. That's what you do space complexity for, is to talk about the data structure that you use. So you have your integer array here. We're given an integer array as input, but I don't want to consider that in the problem. I want to talk about the solution, right? We use an integer array. We have this array here. It's called answer. We know that it's going to be the same length as nums. So let's think about what that really means. They say in the question that nums can go from 0 to I. I is just a variable name though, so let's stick to big N notation, big O notation using the variable N in this case, right? So we know that if the array that we're given is going to be the same size as the array that we output, we can say that, oh, we know that there's one element in here and it's N size. So the space complexity is O of N. Does that make sense? And you have data structures that have access time complexity as well. I do want to speak on that. Like I mentioned earlier, arrays, accessing elements in an array is very quick, but looking for an element in an array can be expensive because you have to go from each element by element, and see what that element is. But I talked about hash maps earlier as well. Inserting items into a hash map is a very cheap operation. It's just putting it in a place in memory and it's associating a key with the value, and the key points to the value in memory. Very cheap. Accessing items, like I mentioned, as long as you have the key, you can access the item. You don't need to search it. It has a very cheap lookup operation. It still takes up the same amount of space complexity, but it boils down to O of N. But technically there's a key and there's a value. So it's really O of 2N, but it boils down in that point, right? Okay, so any questions about the stuff I talk about? How did y'all feel about the pace?
It was good.
Okay.
You
You
can
know-
talk about your next workshop if you want.
Okay, so yeah, that's pretty much the finale of this workshop. I'm really glad that everyone came. I'm glad that I hope you guys liked it. The next workshop we're gonna go back to resume building. I'm gonna go get someone from the Career Center who talks about resumes. My resume, I'm not good at writing resumes, so I really wanted someone else here. But that is, I feel like the piece de resistance. I don't speak French. I hope that was the right thing. But it's like, how do you get these people to even entertain you if you don't have a resume that piques their attention, right? You need to be able to talk about yourself, not in just a braggadocious way, but talk about what you can bring, what's your specialties, what's your passion. But you have to kind of summarize that in one page, and that's pretty tough. And I struggle with that myself, but that's why I'm gonna have someone else out here to do it. And I hope y'all come back. I hope y'all get ready for y'all resumes to be put through the washer by a professional. It's a necessary process. So yeah, y'all come
It's gonna be not next.
the week after next, right?
No, the
Or
week.
no, because you're having
Yeah,
a
so-
workshop.
Yeah, that's why I was gonna say if you want, I can go up there, tell them about like how our flow is gonna be.
Okay. So yeah, that's really the end of the workshop. I know Adam wants to talk about. You want to talk about
Yeah,
those giveaways, right? Okay.
Yeah.
You want to talk about those giveaways? Next workshop will be in a month. I'll give the exact dates will be dropped in Discord. We're hoping to start an email list to communicate. We want to fill this room up. All right. We want to get some great developers working with us. All right. I want everybody to succeed out here. And I came up here to talk, but there's so many talented people in this club that get a chance to come up here and talk. I know they're gonna talk their spill. Y'all don't want to miss it. So, thank you, Adam. You want to talk about the giveaways?
Yeah, thank you, Zay. Hey everyone. So just to start off, kind of taking off where Zay left off real quick, how we're gonna be doing our events and how the workflow is gonna be is it's gonna be about every other week is gonna be an event that gives us time to prepare and actually give y'all a really good workshop that y'all can learn from, and then Zay's industry skills workshop, since I also personally agree with Zay that this is one of the most important things, for college students, right? A lot of people, this topic goes right over their head. So this is a really good thing to reemphasize this and really get y'all in touch with y'all's resume building skills and your interview skills and much, much more, which Zay will expand on that throughout the year. Because with his with his workshop, we're going to be doing that every other week practically. So in between our technical workshops, there will always be Zay's industry skills workshops in between. So plan on trying to show up to those as well, because if you really need the help for your resume and whatnot, it's really beneficial. And I think Zay is doing a really good job so far. So thank you, Zay. So kind of like what we've been mentioning on the Discord, we kind of got some winners from our info session event. We gathered all the names together and did a little giveaway, and we got 5 winners today. And everyone who came to this event online, whether it's on YouTube or in person, everyone here with us, make sure we're going to be releasing a form soon on our Discord. Y'all can fill out, and then you'll have a chance to win as well. So our number 1 winner for our water bottle, I should have actually brought this over here. For our water bottle is going to be Jamar Whitfield. Woo! So Jamar Whitfield, if you're online, or if we're going to be posting this on Discord. So if you're not online or here in person, you could probably still get your rewards. Now for the rest of our awards, we have T-shirts. One goes to Taj Foster. One goes to Aiden Euler, I think. One T-shirt's gonna go to Muhammad Rasul. One's gonna go to Jack Legnan. And then those are gonna be our winners. So thank you guys for showing up to our info session and showing up to this event. I really hope to see y'all in our other events as well. Because once we get more into a track of things, right now you're really gonna see the intro to all of our workshops. You know, the intro to industry skills, the intro to Flutter, intro to cloud computing. But once we get more in depth, and if you're keeping up with us, especially with the workshops you like most, you'll come to find out that we're gonna get in depth into some topics, and you're not gonna want to miss out on those. So thank you everyone for coming today. So it's nice seeing y'all. Make sure y'all stay tuned on our Discord to get any relevant updates and messages. Thank you guys. Y'all have a good one. Let me see how to do the OBS thing.